Okay, welcome back. In the last video, we saw these sums, like which are the following are perfect cubes. Now we are going to find out the smallest multiple that is a perfect cube. Like look at example number 2. It is given that is 392 a perfect cube? So first question is it a cube? Like we have to do it like the previous sum. Then if not, if it is not a perfect cube, find the smallest natural number by which 392 must be multiplied. See, up here difference is it should be multiplied so that the product is a perfect cube. Same way now see, look at the next sum. Is 53240 a perfect cube? So we have to first find out. If not, then by which smallest natural number should 53240 be divided? See, up here it is divided so that the quotient is a perfect cube. Let us do both sums and understand. Before we do these sums, I made a small mistake in the last sum we did up here. See, in the last sum, we had written, I written is 10,640 a perfect cube, and in the last video, we found that it is a perfect cube, and instead of cube, I made a boo-boo and I wrote it's a perfect square, so it should be a perfect cube. Okay, friends. So now let's do this sum. Okay, so is 392 a perfect cube? So what we do first is we find out the factors, the prime factors of 392. So now let's divide. See, the last number is 2, so we can divide 392 by 2. We have 1, remainder 1, so 19, remainder 1, 12, so 196. Again 196 is 6 is divisible by 2, so 196 is divisible. We have 98. 98 is 2, 49s are 98. Now 49 is divisible by 7 only. 7 7s are 49, so 7 1s are 7. So I now can write 392 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 7 multiplied by 7, right? So this now is, see, 2 comes 3 times, right? Now so 2 cube, this is perfect, this is done. But now we have only 2 sevens, 7 into 7. So the question, if you see properly, is 392 a perfect cube? And if not, find the smallest number by which 392 should be multiplied, right? We have to multiply it to make it a perfect cube. So now see, if we have only 2 sevens, right? 1 7 is remaining. So I will now do, therefore 392 multiplied by something is equal to 2 cube into 7 into 7. Now see, if I multiply by 1 7 up here, I'll get 7 cube, right? So I'll multiply by 7 both sides. So now I have 392 into 7 is now equal to 2 cube into 7 cube. Let's multiply this thing, right? So answer is, now see, if I just do 7 2s are 14, carry 1 there, 7 9s are 63 and 1 64, carry 6 there, 7 3 21 and 6 27. So 2 7 4 4 is now equal to 14 cube. Sorry, it should be it should be 14 cube. So answer, what was the question? By which number should 392 multiply? So we write 392 should be multiplied by 7 to make it a perfect cube, right? So we see up here we multiplied this by 7 to make it a perfect cube. Okay, let's see the next sum. Next question is 53240 a perfect cube? If not, then by which smallest natural number should 53240 be divided so the quotient is a perfect cube? So I will start again the same thing. I am first going to find out the prime factors of 53,240, right? So let's do the prime factorization. I am going to divide by 2. This is 2 2s are 4, 2 6 are 12, 2 6 are 12, 2 2s are 4. So we have 26620. Again, if I do 13 2s are 26, 31 2s are 62 and 1 0. Again 2. So I have 2 6 are 12, carry 1 there, 13, 2 6 are 12, carry 1 there, 2 5s are 10, carry 1 there, 2 5s are 10. Now let us see whether this number is divisible by 3, because see, it is not divisible by 4, by 2. So 10 and 12, 22. 22 doesn't come in a table of 3. So this number cannot be divided by 3. Let us divide by 5 now first. 5 1s are 5, carry over 1 there, 16. 5 3s are 15, carry over 1 there. We have 15. 5 3s are 15 and 5 1s are 5. 1331 we know. 1331 is divisible by 11. So 11 121s are, 11 11s are and 11 1s are. So therefore 53,240 can be now written as, you see, we have 3 times 2. 2 into 2 into 2. We have 3 times 11. 11 into 11 into 11, but the number which is alone is only 5. Now, you see, by which number should it be divided so that quotient is a perfect cube? So how do we divide it? So we have to, what is more? For 1 5 is more, right? So what I'm going to do to remove this 5, see, I'm going to do 2 into 2 into 2. Oh, chalo, there is convert. 2 into 2 into 2 is 2 cube, right? 11 into 11 into 11 is 11 cube, and I have only 1 5, right? So to remove this 5, I can divide by 5, right? If I divide by 5, this 5 is cancelled, right? So what I'm going to do up here, same thing I'm going to do up here. 53,240 also I'm going to divide by 5. So now I'll get 2 cube into 11 cube. That is nothing but 23 cube. So answer 53,240 should be divided by 5 to make it a perfect cube. Okay, friends, see. So the same way you can do the sum also, like, is 1188 a perfect cube? If not, by which smallest natural number should 1188 be divided to make it a perfect cube, right? Same thing. Like you can see in this case, 1188 could be written as, say, I only 3 cube is here. What is extra? We have 2 into 2 and 11 will be extra, right? So 2 2s are 4, 4 11s are 44. So if I divide by 44, then it will be a perfect cube, right? Same way, is 68,600 a perfect cube? If not, by which number 68,600 should be multiplied to make it a perfect cube? So again, I'm going to do factors of 68,600. See, I'll get 2 cube, I'll get 7 cube. You see, there are only 2 5s. So 1 5 is left, right? If I multiply this by 5, I'll get a perfect cube. So I'll multiply this by 5, right? So answer is, right, we multiply by 5. Alright, friends. Now check which of the following are perfect cubes. Okay, let's take 2700. Now 2700, if you see one thing, if there were 0 has to be, there has to be 3 zeros. There are only 2 zeros up here, right? So this is not a perfect cube, because if there are 3 zeros, see, suppose I have given 27,000. So now 3 zeros, that is 10 cube, and 27 is nothing but 3 cube, right? So I have 30 cube. 27,000 would be 30 cube, but this is 2 zeros, so it's not a perfect cube. Now you can look at this number, 16,000, right? 1000 is there, 3 zeros are there, but 16 is not a perfect cube, right? See, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64. 16 doesn't come. Look at this, 3, so this is not there, this is not there. 64, now 1000, so this is 10, you see now, 10 cube, and 64 is 4 cube, so I have 40 cube, so this is a perfect cube. 900, see, doesn't make a perfect cube, so it is not there. 125,000, though, see, 1000 is there, that is 0, and 125 is 5, no? So I have 50 cube, so this is a perfect cube. 3600, see, 36,000, 1000 is there, but 36 is not a perfect cube, so not there. 216 is a perfect cube, but 2 zeros, so again not a perfect cube. 10,000, 3 zeros are there, but not 10, not a perfect cube. 27 is a perfect cube, that is 3. Now look at the zeros, 3 zeros and 3 zeros, so I have 300 cube is this number, right? So this is a perfect cube. 1000, see, 3 zeros and 1 cube is 1, so this is 10 cube, so this is a perfect cube. So if you see the pattern, in the pattern we'll observe that there should be 3 zeros or pairs of 3 zeros, like 60, 90, but 3 zeros should be there, and then either it should be 1, or it should be 8, or it should be 27, or it should be 64, or it should be 125, or 216. It means 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, and then 3 zeros would make it 10 cube, 20 cube, 30 cube, 40 cube, 50 cube onwards. Okay guys, we end up here. Now exercise 7.1, this is your homework. This you have to do on your own. See, which of the following numbers are not perfect cubes? Find them out. Right? You can see the last number and find out whether it's not a perfect cube. You can also, right, see whether they're perfect cube by our logic. Then find the smallest number by which each of the following numbers must be multiplied. See, this is what we did in example number 2. Then find the smallest number by which each of the following numbers must be divided. This is what we did in example number 3. Okay, so same sums you do on your own. Parikshit makes a cuboid. Now look at sum number 4. Parikshit makes a cuboid of plasticine of sides 5 semi, 2 semi, 5 semi. How many such cuboids will he need to form a cube? Now see, sides are 5 semi. Okay, so let's say length is 5 centimeter, breadth is 2 centimeter, only 2 centimeter, and the height again is 5 centimeter. So this is one cuboid. Let's see, this is a cuboid. Right? Now, see, this is 5, this is 2, and this is 5. Now I want to make it into a perfect cube, right? So how many such cuboids will he need to form a cube? I want a cube. So now think of it. If this is 5, right, and this is 2, right, I want to make a perfect cuboid. What do I do? How many will I require? Think of it. See, if I put 2 up here, now see, if I put 2 cubes here, one more cube here, I'll get total 10. Total will be 10 centimeter. If I put another cube up here, see, one more up here, right, I'll get height of 10 centimeter. And up here it is only 2 centimeter, so I'll have to put 5 more, right? 5 more. I'll have to put 5 more, right, to this thing. So now this, right, So you see now how many cubes will be required. So you see up here, if I put 2 cubes back to back, I'll have 2 up here, right? In this side we'll have 2. Then we are putting 5 cubes. See, 1, 2, 3, 4, 5 to make 10, right? So up here we'll have 5 more. So 2 into 5, right? 2 into 5, that is in the base there will be 10 cubes, right? In the base we'll require 10 cubes. But same thing, to make 10 here, we are putting again 1 more cube here, means all this 10 more, no? So into 2. So I'll have 20 cubes will be required. Right? If I have 20 cubes, you will see, right? I'll get this whole perfect cuboid. Okay, so 20 cuboids will make 1 cube. Okay friends, we stop here. 7.1 you are to practice. Next topic would be how to make cube roots.